Spring is fireball season, presented by Science at NASA. What are the signs of spring? They are as familiar as a blooming daffodil, a songbird at dawn, a surprising shaft of warmth from the afternoon sun. And oh yes, don't forget the meteors. Spring is fireball season, says Bill Cook of NASA's Meteoroid Environment Office. For reasons we don't fully understand, the rate of bright meteors climbs during the weeks around the vernal equinox. In other seasons, a person willing to watch the sky from dusk to dawn could expect to see around 10 random or sporadic fireballs. A fireball is a meteor brighter than the planet Venus. Earth is bombarded by them as our planet plows through the flotsam and jetsam of space. For example, fragments of broken asteroids and decaying comets that litter the inner solar system. In spring, fireballs are more abundant. Their nightly rate mysteriously climbs 10 to 30%. We've known about this phenomenon for more than 30 years, says Cook. It's not only fireballs that are affected. Meteorite falls, space rocks that actually hit the ground, are more common in spring as well. Meteor expert Peter Brown of the University of Western Ontario notes that some researchers think there might be an intrinsic variation in the meteoroid population along Earth's orbit, with a peak in big fireball-producing debris around spring and early summer. We probably won't know the answer until we learn more about their orbits. To solve this and other puzzles, Cook is setting up a network of smart meteor cameras around the country to photograph fireballs and automatically triangulate their orbits. Networked observations of spring fireballs could ultimately reveal their origin. It might take a few years to collect enough data, he cautions. Until then, it's a beautiful mystery. Go out and enjoy the night sky. It is spring after all. For more information about fireballs and other mysteries, please visit science.nasa.gov. Solar activity heats up, presented by Science at NASA. If you've ever stood in front of a hot stove, watching a pot of water and waiting impatiently for it to boil, you know what it feels like to be a solar physicist. Back in 2008, the solar cycle plunged into the deepest minimum in nearly a century. Sunspots all but vanished, solar flares subsided, and the sun was eerily quiet. We've been waiting ever since for solar activity to pick up, says Dick Fisher, head of the Heliophysics division at NASA headquarters in Washington, D.C. We've been waiting 3 long years. Quiet spells on the sun are nothing new. They come along every 11 years or so. It's a natural part of the solar cycle. This particular solar minimum, however, was lasting longer than usual, prompting some researchers to wonder if it would ever end. Now the pot is starting to boil. Finally, says Fisher, we're beginning to see some action. As 2011 unfolds, sunspots have returned, and they are crackling with activity. In February and March, Earth-orbiting satellites detected a pair of X-flares, the brightest X-ray solar flares since 2006. Another eruption in March hurled a billion-ton cloud of plasma away from the sun at 5 million miles per hour. The rapidly expanding cloud, known as a coronal mass ejection, wasn't aimed directly at Earth, but it did deliver a glancing blow to our planet's magnetic field. The off-center impact was enough to send northern lights spilling over the Canadian border into U.S. states such as Wisconsin, Minnesota, and Michigan. That was the fastest coronal mass ejection in almost 6 years, says Angelos Forlidas of the Naval Research Lab in Washington, D.C. It reminds me of a similar event back in November 1997 that kicked off solar cycle number 23. I'd say solar cycle number 24 is now underway. The slow buildup to this moment is more than just the watched pot failing to boil, says Ron Turner, a solar physicist at Analytic Services Incorporated. It really has been historically slow. There have been 24 solar cycles since astronomers started keeping track of them in the 18th century. An analysis just published by Turner in the journal Space Weather shows that in all that time, only 4 cycles have started more slowly than this one. Better late than never. For more information about solar activity and other hot topics, visit science.nasa.gov. Meteors from Halley's Comet, presented by Science at NASA. Mark your calendar. In the year 2061, Halley's Comet will return to the inner solar system and put on a wonderful show for skywatchers around the world. Astronomers say they can't wait. No kidding. Who can wait 50 years? Many of us will be long gone by the time Halley gets back. Fortunately, there is another viewing opportunity right around the corner, on May 6, 2011. That's when Halley's Comet will produce a lovely spring meteor shower called the Eta Aquarids. Although the comet itself is beyond the orbit of Neptune and won't return for 5 decades, Halley's trail of dusty debris stretches all the way back to Earth. On May 6th, our planet will pass through a flowing stream of Halley dust. Disintegrating bits of Halley's Comet will shoot out of the constellation Aquarius in the form of bright meteors, a nice show for anyone willing to wake up early enough to see it. The best time to look is between 3:30 a.m. and sunrise. That's when the constellation Aquarius is well above the horizon. Observers in the southern hemisphere are favored. They will count about 40 meteors per hour. In the United States, people can expect to see about a quarter of that number. For best results, get away from city lights. Dress warmly, spread a comfortable blanket on the ground, and lie back so you have a good view of the entire sky. Eta Aquarids are fast, moving at about 148,000 miles per hour. They often trace long paths across the sky, sometimes leaving glowing, smoky plumes in their wake. Earth passes through Halley's long tail every year around this time. But the shower isn't always the same. Dust sputters from the comet in uneven bursts, producing regions of high and low dust density. Sometimes Earth passes through a denser cloud of debris, and this can produce an extra lovely display. Because the meteor rate can be variable and somewhat unpredictable, the International Meteor Organization states that the shower would benefit from increased observer activity. In other words, wake up early and enjoy the show. It beats waiting until 2061. For more information about the Eta Aquarid meteor shower and other marvels of the night sky, please visit science.nasa.gov.
Voyager set to enter the Milky Way, presented by Science at NASA. More than 30 years after they left Earth, NASA's twin Voyager probes are now at the edge of the solar system. Not only that, they're still working. And with each passing day, they are beaming back a message that, to scientists, is both unsettling and thrilling. The message is, expect the unexpected. It's uncanny, says Ed Stone of JPL, Voyager project scientist since 1972. Voyager 1 and 2 seem to have a knack for making discoveries. On April 28, 2011, NASA held a press conference to reflect on what the Voyager mission has accomplished, and to preview what lies ahead as the probes prepare to enter the realm of the Milky Way itself. The Voyager adventure began in the late 1970s and 80s, when the probes took a grand tour of the outer planets. Voyager 1 visited Jupiter and Saturn, while Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune. Voyager 2 is still the only probe to visit Uranus and Neptune. When pressed to name the top discoveries from those encounters, Stone pauses, not for lack of material, but rather an embarrassment of riches. It's so hard to choose, he says. There was the discovery of volcanoes on Jupiter's moon Io, evidence for an underground ocean on Europa, hints of methane rain on Saturn's moon Titan, the crazily tipped magnetic poles of Uranus and Neptune, planetary winds that blow faster and faster with increasing distance from the sun. Each of these discoveries changed the way we thought of other worlds, says Stone. In 1980, Voyager 1 used the gravity of Saturn to fling itself, slingshot style, out of the plane of the solar system. In 1989, Voyager 2 got a similar assist from Neptune. Both probes set sail into the void. Sailing into the void sounds like a quiet time, but the discoveries have continued. Voyager 1 and 2 are now at the edge of the solar system in a place called the Heliosheath, where the solar wind meets interstellar gas for the first time. This is a very strange place, filled with a magnetic froth no spacecraft has ever encountered before, echoing with low-frequency radio bursts heard only in the outer reaches of the solar system, so far from home that the sun is a mere pinprick of light. In many ways, the Heliosheath is not like our models predicted, says Stone. Soon, in a matter of years, the two probes will leave the solar system altogether, and enter the realm of the stars, interstellar space, the Milky Way itself. Then they will have a new job, ambassador. Each probe is famously equipped with a golden record, literally a gold-coated copper phonograph record. It contains more than 100 photographs of Earth, 90 minutes of the world's greatest music, an audio essay entitled Sounds of Earth, featuring everything from burbling mud pots to barking dogs and a roaring Saturn V liftoff, greetings in 60 human languages and 1 whale language, and the brainwaves of a young woman in love. A team led by Carl Sagan assembled the record as a message to possible extraterrestrial civilizations that might encounter the spacecraft. Some people say that the chance of aliens finding the golden record is fantastically remote. The Voyager probes won't come within a few light years of another star for some 40,000 years. What are the odds of making contact under such circumstances? On the other hand, what are the odds of a race of primates evolving to sentience, developing spaceflight, and sending the sound of barking dogs into the cosmos? Expect the unexpected indeed. For more information about Voyager and other mind-blowing NASA missions, please visit science.nasa.gov.